Hello. Now we are going to discuss the remaining problems as a part of our regular class session. Four problems were discussed. Now we'll see the remaining five problems. So the question is here. A sample of dry cohesionless soil was tested in a triaxial machine. If the angle of internal friction is 36 degrees, confining pressure is 100 kPa. Determine the deviator stress at which the sample has failed. So now the question goes on like this. They are asking you to calculate the deviator stress, right? And let us tabulate the given things. Yeah. So they mention the soil as cohesionless soil. It means that C is equal to 0. And the soil has been tested in triaxial machine. And the phi value has been reported as 36 degrees. And sigma C confining pressure or minor principal stress sigma 3 equal to 100 kPa. So these are the given parameters. Now they are asking us to calculate the deviator stress, which is sigma D, or otherwise I can say sigma 1 minus sigma 3. How much is that is being asked. Now let us apply our Moore Coulomb failure criteria. Sigma 1 is equal sigma 3 tan square alpha plus 2c tan alpha. Right? So now whatever is given here, just write it down. Just substitute the values. So we know what is sigma. We don't know what is sigma 1. Just maintain it. And sigma 3 is being mentioned as 100 kPa. Substitute the value as 100 kPa. And tan square alpha. So we know just phi value is 36 degree. We can even substitute it here. Tan square 45 degree plus 5 by 2. So 36 by 2. We may get 18 degrees. 2c tan alpha won't be there. So this will be entirely 0. So how much is sigma 1? So sigma 1 is equal to 100 tan square 45 degree plus 18. Shall we get that value? So we will get 300 and 1 minute. Yeah. So we will get our answer as 385.18 kPa. So our deviator stress, this implies sigma 1 minus sigma 3, which is equal to sigma D, is 285.18 kPa. Is that right? Yes. Right. Now we'll move on to the next problem. Problem number 6. A CU test was conducted on a normally consolidated clay and the following are obtained. Sigma 3 is 250 kPa and sigma D is equal to 275 kPa. Determine shear parameters. See, as we have discussed in the class, in case of consolidated undrained test, how much is the C value of clay? Even though it is a normally consolidated clay, when you perform a consolidated undrained test, the clay, you are not allowing the drainage to go off. So the entire clay will become like a slurry and there will not be any cohesion to the soil. So C is equal to 0 at CU test on NC clays. Okay. So even though it is a clay, C is equal to 0 if you perform consolidated undrained test. So remember this concept. So using this relation, we are going to determine the shear parameter. Already we have determined one shear parameter. Our only thing is to determine how much is the phi value. So sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha, right? Our relationship. So here C is 0, so we don't have the second term on the LHS. So what is sigma 1? So sigma 1 is not directly given, instead sigma D is given. So let us determine what is sigma 1 from sigma D. So sigma 3 is 250. So sigma 1 minus sigma 3 is 275 kPa. And sigma 1 is equal to 275 plus our sigma 3 is 250 kPa. So add this 250, so you will get 525 kPa, right? So 525 kPa is your sigma 1's value. Just substitute it in our main equation. You will get sigma 1, which is 525 kPa, is equal to sigma 3, which is just 250 kPa, equal to tan square alpha. So once you resolve this, you will get alpha is equal to 55.39 degrees, and hence how much is your phi value then? So for phi, we can write from alpha, 1 minute. So alpha is nothing but 45 degree plus 5 by 2, right? So appudu 5 by 2 is equal to 55.39 minus 45, which gives us the value as 10.39 degrees, and hence phi is equal to 10 into, so I can write it as 10.4 degrees. So here our phi is almost equal to 20.8 degrees. So this is our phi values. So we have determined our shear parameter. So if you ask me to calculate the shear strength tau, you can even report the shear strength tau. So which is tau is equal to C plus sigma tan phi. See, here we don't know how much is our normal stress. Instead, what you could do is you can use our other relationship, which gives us tau is equal to sigma 1 minus sigma 3 by 2 sine, it is 2 theta. Now our theta is 45 degree plus 5 by 2, which is alpha. So sine 2 alpha. Once you substitute the value for sigma 1, sigma 3 and alpha, you will get tau as 128.54 kPa. Okay, fine. Now we will move on to the next problem. Following are the test results of undrained triaxial compression test on two identical soil specimen at failure. So test 1 results are sigma 3 is 100 kPa and sigma 1 is 400 kPa, 440 kPa, I'm sorry, and U is minus 20 kPa. And for in the test 2 we got our results as the confining pressure as 300 kPa, and sigma 1 is 760 kPa and U is 60 kPa, and all these are in terms of kilopascal. And I guess in your question it has been given as 30 kPa. It's not 30, just corrected, it is 300 kPa. Determine C and phi at total and effective stress condition. So this is the question being asked. So our famous relationship of sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So in a same for a same soil, undrained triaxial compression test has been performed and the result obtained are listed here. They are asking us to determine C5 values at total stress condition as well as at effective stress condition. See, at total stress condition, you can directly take the normal stresses, whereas at effective stress condition, you have to incorporate pore water pressure also. Okay. So, for the first test, you got your equation as 440 is equal to sigma 3, which is 100 tan square alpha plus 2c tan alpha, right? And for the second test, you will get the equation as 760 kPa is equal to 300 tan square alpha plus 2c tan alpha, right? So you got two equations. You can resolve these equation in any way. So what's the easiest way you can do? So just subtract them. Subtract this equation from this equation. So 2c tan alpha, 2c tan alpha may get cancelled. So minus, here you will get somewhere around 320 is equal to minus 200 tan square alpha, which is nothing but which gives you your alpha value as 51.5 degrees. If alpha is 51.5 degree, this implies our phi is equal to, just substitute for alpha 45 degree plus 5 by 2, our failure plane inclination. So phi is equal to 13 degrees. Okay. Once you get phi as 13 degree, substitute this in our any one of the tests equation. So if you substitute it, then you will get, for example, I'll just do here 440, 100 tan square 51.5 degrees plus 2c tan 51.5 degrees, right? So if you solve this, you will get C value as 113 kPa, right? That's it. Now with this, the problem is not over. Now we will solve the same problem as effective stress condition. So under effective stress condition. So under effective stress condition, the major thing which you have to note here is you have to consider the pore water pressure. So our sigma 1 will become 420 because here negative pore pressure is there. So this one will become 420 and this one will become 120. Whereas this will become 700 and this will be 240. So if you write the equation, then you will get 460 kPa is equal to 120 tan square alpha for test 1, okay, plus 2c tan alpha, and in case of test 2, if I substitute the values, 700 equal to 240 in the content, 300 minus 60. 60 is the core water pressure. 300 minus 60, which is 240 plus 2c tan alpha. What are you supposed to do? Just subtract it. This one will get cancelled. Then you will get somewhere around minus 240 is equal to minus 120 tan square alpha. Right? So this minus and minus will get cancelled, and finally you will get alpha value as somewhere around 54.7 degrees. This gives you phi value as 19.4 degrees. How you got this value? Because alpha is nothing but 45 degree plus 5 by 2, right? So from this relation only I got phi value as 19.4 degrees. So if phi is 19.4 degrees, so our equation of 460 is equal to 120 tan square 54.7 plus 2c tan 54.7. If you do this on simplification, you will get your C value as 78.33 kp. That's it. Now let us move on to the next problem. Yes, a saturated specimen of cohesionless sand was tested in triaxial compression, and the sample failed at a deviator stress of 482 kPa when the confining pressure was 100 kPa under drained condition. Find out phi dash what would be the deviator stress and major principal stress at failure for another identical specimen of sand if it is tested under a confining pressure of 200 kPa. See, the question is very simple, and we have solved similar question during your classroom session also. So here initially, a triaxial test was performed on sand. Since it is sand, we came to know that C is equal to 0. And first, a test 1 was performed. So, from this test 1, they have applied a deviator stress sigma D as 482 kPa and sigma 3 or sigma C as 100 kPa, and with this stress condition determine how much is your phi value. And after that what they explained is there is a second test at which the confining pressure value is given, and they are asking you what would be the deviator stress. Okay, so first we'll substitute the values of test 1 in our equation. Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, right? So we'll get our sigma 1 value. So here sigma D alone is given. So what is sigma 1 then? So sigma 1 minus sigma 3 is 482. What is sigma 1 then? 482 plus sigma 3, which is 582 kPa, right? So 582 is equal to 100 tan square alpha. No need to worry about this term because it's a cohesionless sand in which C will be equal to 0, right? So we will get on substitution we will get our alpha value, and from alpha value finally I got my phi value as 44.97 degrees. Okay, I guess it's a well done son because we got our phi value as 44.97 degrees, which is almost the frictional angle for a weathered rock or a very highly dense sand. Fine. So now let us move on to the test 2. And the test 2 is performed on the similar sample. Okay, but at a confining pressure sigma 3 or sigma c at 200 kPa. That's it. See, the sample is same. So our phi value is same. Okay, because phi is material property. Since same material, same phi value we are supposed to consider. Now, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Anyway, c is not there. So, this term is equal to 0. And sigma 1 we don't know. And sigma 3 is 200. And tan square alpha, we know what alpha is. 45 degree plus 44.97 by 2. Okay. So this gives our sigma 1 as 482 kPa. See, you have to be careful. In case of competitive exams, many people used to substitute or answer deviator stress as 482 kPa. Mind it, this is not deviator stress. This is major principal stress. So, calculate how much is your deviator stress. Sigma 1 minus sigma 3. So 482 minus 200 kPa, that gives us the answer as 282 kPa of deviator stress. This is the final answer. Right? Shall we move on to the next question? Yes. Oh my god. Yes. Here is our question. A consolidation A consolidated drained triaxial test was conducted on a granular soil at failure sigma 1 dash by sigma 3 dash is equal to 4. The effective minor principal stress at failure was 100 kilonewton per meter square. Compute phi dash and the principal stress difference at failure. See, in this question, a triaxial test has been performed on a granular soil. The moment the soil has been reported as granular soil, C is equal to 0. And then they are asking us to calculate how much is the friction angle at effective stress condition and the difference between sigma 1 dash and sigma 3 dash. That's it. Okay. And they told the effective minor principal stress at failure is 100 kilonewton per meter square. The question is very simple. So our answer also will be very simple. You just see, we need phi value. And our equation is sigma 1 dash is equal to sigma 3 dash tan square alpha plus 2c tan alpha, right? Anyways, everything has to be in effective stress condition. This fellow will not be there. So since E is 0, this term will not be there. Only we have to consider these two terms. So sigma 1 dash I don't know. So sigma 1 dash by sigma 3 dash is equal to tan square alpha. Right? Sigma 1 by sigma 3 is a ratio and the ratio is 4. So tan square alpha is equal to 4. So tan alpha you just take a root. So finally you will get alpha value as 63.4 degrees. Okay. So since alpha is 63.4 degrees, our 45 degree plus 5 by 2 is once again 63.4 degrees. That gives you your phi value as 36.8 degrees, right? Fine. And this is not phi, this is phi dash because we are substituting everything in at effective stress condition. The next one is what is the difference between the principal stresses? Okay, it is very easy because they told sigma 1 dash by sigma 3 dash is equal to 4. Hence, sigma 1 dash is 4 times of sigma 3 dash. How much is sigma 3 dash? Is 100 kPa as given in the question. So, your sigma 1 dash is 400 kPa. If this is 400 kPa, how much will be the difference then? So sigma 1 dash minus sigma 3 dash is equal to 400 minus 100, which is just 300 kPa. Fine. Now, this is the answer. We'll move on to the next question. When an undrained triaxial compression test was conducted on specimen of clayey silt, the following results were obtained. Sigma 3 at test 1 is 17 kPa or kilonewton per meter square, and sigma 1 is 157, pore water pressure is 12, and on test 2 you got your sigma 3 value as 44 and sigma 1 value as 204 and pore water pressure is 20, and on test 3 your sigma 3 is 56 and sigma 1 is 225 and u is equal to 22. Determine the values of shear parameters considering total stress and effective stress condition. So this is similar to our seventh problem. So I'll directly start answering. So and three set of tests are being conducted and they are asking us to determine phi values at total stress and effective stress conditions. Okay. So our equation is sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. So from the first test, 157. See, sometimes in the question they give deviated stress. Sometimes they directly give major principal stress. So you have to be careful in substituting the value of sigma 1 and make sure whether it is sigma 1 or sigma d given in the question. 157 to 17 tan square alpha plus 2c tan alpha, and then our next equation will be 204 equal to 44 tan square alpha plus 2c tan alpha. So if you just subtract one equation from the other, then you will get your values as 47 is equal to 27 tan square alpha. Hence, alpha equal to 52.8 degrees. Finally, our phi is equal to 15.68 degrees. Once you substitute this phi value in either of your equation, you will get, or I could say, 2c tan alpha is equal to 157 minus 17 tan square 52.8 degrees. On solving this equation, you will get, here also substitute alpha value. So you will get your C value as 48.38 kilonewton per meter square or kPa. Right? That's it. And the same one you can even solve at effective stress conditions. I'll just write the equation. You can do it on your own. See, for the first test, I'll start from here under effective stress condition. So your sigma 1 will become 157 minus 12, which is 145 is equal to 17 minus 12, which is just 5 tan square alpha plus 2c tan alpha. Coming to the second set results, so you have to subtract 20 pore water pressure to get effective stress condition. So you will get 184 is equal to 44 minus 20, which is 24 tan square alpha plus 2c tan alpha. So just simplify this equation or solve this equation, I could say. So these two terms will get cancelled. Then you just subtract and find out how much is your alpha. So once you get alpha value, you can report how much is your phi. And once you get phi value, what would be the next step? How much is the C value? So once you do that, your problem is over. That's it. Thank you.